a low pitch slate roof, you can walk on it. You stand on the middle of the slates, and they don't break. If if the slates are breaking, the roof is failing, and you should see that before you get on it. But you're certainly not required by any standard to walk on the roof. Here you can see this is a hard purple slate, probably came out of Vermont. Various sizes, very nice roof, really tremendously expensive roof. You just don't see anything like this installed in new construction. Well, I don't know. I don't inspect the $5 and $10 million houses, but I still don't think they're putting these roofs on. Minor repairs, but these slates really, even though they're probably close to 100 years old, there's nothing wrong with the slates. That's just moss. And one thing you would never tell somebody to do is power wash, well, any roof, but certainly not a slate roof. When you're in an attic with a slate roof, you will see daylight. The slates don't sit flat. So you're looking for big pieces of daylight or missing slates. Here you can see a slate's problem has been repaired. You can see tar repairs there. And again, this is, these roofs will be nursed along with repairs for potentially decades. Material deterioration, here you can see a soft slate where the slates themselves are just basically crumbling, they're delaminating. Somebody spent a lot of money repairing this, but the rest of the slates are, just continuing to deteriorate behind all the repairs. But they did a very nice job. They replaced the flashing, new copper flashing, Copper Valley flashing, but again, you can see these slates themselves, they're still crumbling. So ultimately, this roof has a finite life. What that definition of finite in is, anybody's guess. Anytime I see a wooden roof, I just tell my clients, I'm very sorry for you. Wood shingles, wood shakes used to have tremendous durability. Wooden roof on a house, a wood shingle roof on a house was generally triple coverage, could last 50, 70 years, but the shingles and shakes these days have no decay and disease resistance. When they were cutting down, 100-year-old cedar trees and splitting the shingles out of the 100-year-old wood, those shingles would last, quite a long time. Now the trees are grown 20, 30, 40 years. They're cut down, made into shingles, shakes, and, 10 to 15 years is pretty much typical life expectancy for a new wood roof. And they're expensive. They're very expensive. Materials are expensive, and every shingle, every shake, and actually every slate has 2 nails in it. So they're very labor intensive. Here you can see the wood shingles are cupping, lifting, so wind-driven rain can get under it. Wood shingles have an underlayment. Wood shakes have an interlayment, where with every layer of shakes, and shakes are the larger hand-split materials, a wooden shingle or shingles are 16 or 18 inches, usually installed 5 to 7 inch exposure. Wood shakes are 24 inches long, installed with 10 or 10 inches, 9 or 10 inch exposure. And again, they have a hand split surface, so they're much more rugged looking. When they start to curl and lift, water can drive in under. The shakes have a layer of felt paper installed with every row of shakes. So actually the shakes protect the felt paper. The felt paper is keeping the roof dry. You're looking at a shake roof and you can see the interlayment, because it's not underlayment, it's in the shakes. If you can see the interlayment, the roof is on its way out. It's failing. This again is a shake roof. The shakes are lifting, and if you could get on that roof, you would see the interlayment in the shakes. I mean, that roof is pretty well gone. It may not be leaking. A lot of times on an old barn, you can look and see daylight, but when the rain hits the wooden shingles, they'll swell and seal. Also, wooden roofs can be installed with no underlayment. a new wood roof, a lot of times they put them on solid sheathing with an underlayment beneath them. There's a lot of people that feel that when you install a shingle or shake roof on space sheathing with no underlayment, the air can circulate underneath the shake and they can dry out. They last longer. When you put it on solid sheathing with felt paper under it, the underside has no air circulation. The water is trapped. And, again, a lot of people feel that compromises the length of the longevity of the material. With the roofing, the flashings are critical. With any system, it's the details. In roof installations, it's the flashings. Flashings at the penetrations, your plumbing and other vent pipe penetrations, furnaces, metal, chimneys, metal and masonry. The intersections, the intersection between the roof and a wall. You're also looking at the valleys. A lot of times the roof will leak at a valley. Also looking where a roof changes in pitch between a steeper roof and a low pitch roof. The code calls for flashing in these areas. You don't know if it's flash, but you're looking underneath those areas for signs of leaks. You're also looking again for problematic designs and installations. Sometimes the architect or whoever is designing an addition or designing a roof initially just will design for the appearance, and they'll say the roofer will be able to make this not leak. And some situations, simply the roofer, no matter what he does, it's going to leak under the right situations or the wrong conditions. This is ideally what you want to see. This is a counter flashing, galvanized, or it used to be even lead, set into a reglet in the masonry wall. There's a step flashing in each shingle, just like you have with vinyl siding or hardy plank, and then the counter flashing goes down over top of it, makes a nice seal. The two-piece flashing system, the step flashing and the counter flashings, allow the wood structure to move in relation to the masonry. Wood expands and contracts with temperature and humidity. Masonry basically doesn't move. So the masonry doesn't move, the wood moves. If it's a one-piece flashing in this area, that flashing is subject to the movement of the wood roof and will ultimately start to fatigue and fail. This was aluminum siding and a second layer of shingles. You had to look closely, and here I got up on my ladder. I wasn't climbing the roof, but got right next to the dormer. I could see that the second layer of shingles was just installed to the aluminum siding. What was keeping the dormers dry was the flashing, the step flashing that was installed in the original roof. That flashing went under the aluminum siding. So the only thing I could recommend my client do until they replaced the roof was a couple more years, but really not a lot of life left, was just install sealant at this location, just try and keep the water from getting to the first roof and to the flashings underneath. Plumbing and other penetrations through the roof. This is something you don't see very much, but this is a lead boot installed. It actually goes over the entire pipe and is folded down inside the pipe. Lead flashing like this will outlast these shingles. It will last longer than 2 or potentially 3 roofs, as long as nobody puts a nail through it. This is what you see very commonly, the rubber boots just failing, cracking, sealed time and time again. That's a leak. When you're in the bathroom and you see the stain on the bathroom ceiling right near the wall, that's the vent pipe going through the roof, the collar's cracked. You'll see the stains in the attic, and you get up on the roof, you'll see the cracked boots. There are easy ways to fix this. I've seen where they just get a rubber boot and just put it down over top of it. Sometimes they'll take a whole flashing, put it down over top of it, and there's a basically a hard plastic I think it's not roof helmet. I'm thinking gutter helmet. It's basically looks like a helmet, but fits down over the vent pipe, covers this whole shooting match, and is good basically forever. But these are leaks, so you don't want to miss them. Here the boot's just gone. Copper vent pipe. The shingles are fine, but looks like when they replaced the roof, they just reused the old flashing. Here, this is probably the plumber putting the flashing in. The roofer wouldn't have done that. Basically shoved it under the shingles. Here you've got water penetration. It's caulked, but the water just, is down in under it. It's going to find the hole at the vent pipe, and down into the house it goes. Again, similar situation, just more fasteners, better fasteners, but more holes, more sealant. That's just not a roofer doing that. That's the plumber. This is ideally how the flashing should be installed in a metal roof. There's a slot. Here you can see it's not just a slot, but a U shape, and then tees out at the bottom. The plumbing vent flashing is slid up underneath that, and then the pipe is installed. You've got to put that flashing in the roof before you put the pipe up through it. You can't retrofit that. This is the retrofit. This is the ideal situation. I've only seen that a couple times, that flashing installation. It's the same roofing company that did the gutter straps attached to the standing seams. Again, extraordinarily nice metal roof installation. Your chimneys. Through the roof, adjacent to the roof. We saw where the flashing was installed in the reglets, the open mortar joints, and then been in and installed. That is the exception today. The rule is you'll have the step flashings installed. This is your counter flashing, but it's just nailed to the masonry, and then the top of that is just sealed with caulk or roof cement. So every 2 to 3 years, somebody just needs to get up there, take a look at that. If it's cracked, reseal it, or if they're up there, just reseal it anyway. The metal expands and contracts and just is constantly working to try and pull away from the brick, and sooner or later it will. Here you've got a roof draining into a chimney with a mansard roof, shingles for the mansard, and this has been leaking for decades, if not generations. You're just looking at repair after repair, tar, paint, caulk, white paint, tar. It's just leaking. The proper repair for this is actually build a little cricket, a little triangular roof that will actually catch the water going down and divert it out and around the chimney rather than letting the roof drain into the back of the chimney. To install a cricket, basically this entire thing gets taken apart, and with an old metal roof like this, a repair like that is difficult, and so people will just continue to tar it until they replace the metal roof. Again, you can just see water's just ponding there. It's just looking for, there are holes in there. You can see the sealant just pulling away and cracking, and so it just leaks and leaks. Any chimney over 30 inches wide should have the cricket, the perpendicular roof installed behind it with valleys shedding the water around the chimney. Sometimes they're there, sometimes they're not. Sometimes this flashing will work. This is a case where looking at the roof that that's leaking. They just took drip edge and nailed it down to the roof and caulked and tarred multiple times, again in an attempt to drain the water around the chimney, because they didn't want to take the roof apart and build a cricket in there. They didn't want to do the right thing. So all these are, these are leaks. If it's not leaking this rain, it's just a leak. There's no, yes, somebody doesn't need to evaluate it. It's a leak. It needs to be taken apart and rebuilt properly. Here they put the chimney at a 45-degree fireplace and chimneys 45 degrees in the house in an attempt to get the water to drain around the chimney. It's a big chimney, but again, you can see with just multiple attempts at trying to get this to not leak. And with a chimney like this, you can actually get water leaking down in through the crown, through the cracks in the crown. The brick itself can absorb water, and you can get water down, 1 or 2 stories down that's actually coming in through the masonry. And sometimes people are out there slathering tar on the roof in an attempt to get the chimney to stop leaking when it's actually the masonry itself rather than the roof. But a situation like this, again, multiple people are up there trying everything they can think of. And with a chimney on a diagonal, even figuring out how to build a cricket in that would be an interesting proposition. Certainly something could be done. How do you create a roofer's nightmare? You collect a ton of water in a valley, you build a giant chimney, and you put it at the bottom of the valley. The initial installation was a really nice piece of metal work in there, flat seam metal, solder joints, little cricket on this side. Couldn't put a cricket there. Well, could have done a cricket, but they just did a large valley. But again, over time, there's metal movement and fatigue where the metal just fails. And then people just get in there and just start to caulk and tar and do all kinds of things. That's a leak. If not immediately, then soon that will just leak again. It's been repaired, and the repairs are just not permanent. Here, you've got a little tiny cricket built behind a concrete block chimney. Somebody just put the manufactured stone over top of it. Virtually impossible to repair this situation when things start to leak. You have to take the stone off to get to the flashings. Nice flashing. Somebody's actually chaining their antenna. They were sure that antenna was not going to blow off unless the 2x4 cracked. Even did a very nice job of putting a T on the iron pipe, the galvanized pipe holding the antenna mast so it wouldn't poke a hole in the roof. And turnbuckles on the chains. Of course, the cap on the chimney is probably cracked and leaking and letting water down in through the chimney. Here's your counter flashing set into reglets, so very nice, and somebody just had to have their antenna. Here you can see the top of the chimney is deteriorating. Flashing is just sealed to the brick, and when you've got the joints in the brick, the mortar joints, your sealant is hard pressed to seal those tightly. So just the only thing that can be done at this point is just keep resealing it, and ultimately it's kind of a small chimney to put step flashing and counter flashing in, but that's what should be done. Here again, a large chimney. Somebody just really didn't have any idea what to do with the flashing, and nobody could see it from the ground, so the guarantee was up when the check cleared, and it's just leaking. And just stare above the fireplaces, stare at the ceiling above the fireplaces. But even if it's perfect, go in the attic. You want to look at this, remember where this is when you go in the attic, and check the area above the fireplace. Most times you can see that chimney in the attic. You're looking for stain sheathing, rot, repairs, new sheathing. But this, these are leaks. This was the slate roof I saw yesterday. There's actually an attic hatch that somebody could get out on the roof and clean the chimney, work on the chimney, repair the roof. Somebody's got a little solar powered exhaust fan in one of the gable vents, and that's the solar panel for it. But you can see here the stone ledge and then the flashing goes up under the ledge and is sealed to it. So that was how a lot of times they didn't put any counter flashing. They just hung the masonry out, ran the metal roof underneath the masonry, and let the water just drip off the masonry. And it would most times just miss that. This one had been leaking. There's a lot of stains. So putting the metal hatch immediately adjacent to the chimney certainly just, provided an area where no matter what you did with the flashing, there was basically built-in leaks in the situation. But this was a 200-year-old house. I don't know that that roof framing is 200 years old. It may have had a new roof installed on it at one point. 200-year-old house most likely would have had a wood shake roof rather than a slate roof. So a lot of times they would just take the old roof framing off, put a new roof frame on. Here you can see the rafter used to have a collar tie, and again, it's leaking. I think I'm getting a signal that this is time for your meeting, and then I will be back at 7:30. Is that correct, Hollis?
I meant that to be a 5-minute reminder.
Oh, okay. I got 5 more minutes. All right. Thank you. Roof wall intersections, your flashings. No matter what you do with Texture 111 plywood, you're going to get leaks. The counter flashing should be under the Texture 111 plywood before that plywood is installed. Here you basically just have leaks. You fill the vulnerable area with holes by putting lots of fasteners in it, and then you just attempt to seal it. These are leaks. Texture 111, the plywood sidings, any flashing should be under the plywood. Anytime there's a flashing installed on the plywood, it's just a leak. Here, for whatever reason, the window was in the roof framing, whether it was an addition out the back or somebody, that's just what they built. Metal roof system installed in the cutout, nicely flashed, and the windowsill is not sitting down on the roof. So odds are pretty reasonable that, has worked successfully from the day it was installed. Aim a roof at a wall, dump a downspout with lots of water at that vulnerable situation, at that vulnerable area, and you basically have a guaranteed recipe for a leak. And you can just see, again, attempts at repairs, whether you can see it or not inside, there's a leak, and let the cable guy put the cable TV wire through there, a few inches underneath the downspout outlet. Silly at best, and it's a leak. It should be ideally taken apart, slashed properly, and also the downspout should be extended out onto the field of the shingles rather than just terminating right there. Not going to look great, but you're getting the water out of the vulnerable situation. Here you've got a step flashing and then a counter flashing just run to the underside of the wood clapboards and then sealed. Again, that's reasonable. Again, it needs maintenance, but that probably will work very effectively. Then they run down into the corner board and it didn't work so well there. So they did bend the top, put a caulk joint, and it has been leaking because they were caulking the corners of the boards. They were caulking all this. Just, the water just came down and actually may have been getting in the intersection here at the back of the corner trim and just sneaking its way in. So, they're thinking the water's coming in up top there. It most likely is just coming in right where the roof runs into the back of that corner trim. The flashing should have gone behind that corner trim and then the wood trim be installed. But the roofer's not a carpenter. He's not going to take the trim off, install his flashing, put the trim back. He's going to do whatever he can to avoid pulling that wood off and actually flashing it properly. Again, this is just, you know, amateur work, step flashings, no counter flashings, a German siding with a profile to it, and just load it up with caulk or tar, and, you know, it's leaking almost immediately, and no amount of repairs will actually, you know, fix that. Ideally, the siding would be cut back, step flashing, and then a trim board installed with a flashing under the cut over the trim board. That's one suggestion, and you're not obligated to make suggestions, but, you know, this is just abysmal leaking, and, you know, again, you don't need to bring a specialist out other than to determine what will it cost to fix that. That is a problem. And I believe we're 7 o'clock, time for your meeting now.
Yep. Dave, thank you. That was a wonderful first hour.
Okay, and we've got 7:30 as when it picks up again?
Yes.
All right, super. Thank you.
Mm-hmm. Hollis, can I get the screen back again?
Current slide, and I think we're ready. We should be good to go now.
Yep.
I do have my GoToMeeting sidebar up, so I really, in giving the web presentations, I'm talking into an apparent void. I know there's people out there, at least I hope there's people out there listening to some degree, but I am
here
at my chat box. So if you have questions, you and the crickets, just please feel free to enter a question in the chat box, and you know, I should be able to see it, or, you know, jump in and just ask me. Otherwise, I'll feel that what I'm saying is gospel and there's no other opinions to be had, and that you all either are learning everything without any questions with my perfect presentation, or you're all asleep or just wandered off doing something else, leaving your computer on, all of which are acceptable by me. All right. Again, we're in situations that were just bad design, bad to begin with. When you take a roof and drain it into a window, the side of a window, no kick-out flashing, an area that's absolutely impossible to flash. You know, just look inside. If you don't see signs of leaks on a home that's had that situation exist for a while, it just means the signs of leaks have been painted over, and, you know, the drywall's been fixed and the paint's been redone. Kick-out flashings, they are now in the code. They have been in the code for 10, 15, 20 years, and they are now starting to really actually, you know, look to see that they are there. In new construction, this is a little teeny kick-out flashing. If you don't know what a kick-out flashing is, you should certainly, but basically, water running down the roof should be directed away from the sidewall and kicked out into the adjacent gutter. That's what a kick-out flashing does. They should be a minimum of, I believe, 5 inches tall and 3 or 4 inches wide. So you should see basically a big piece of metal, and you can see these from the ground. If they're not there, you should definitely be recommending that they be installed, or at a minimum, where the J channel ends, just caulk that intersection to have the water head out and not behind the siding. Here
Dave?
again, there's a kick out. Yes, sir.
Also, the gutter ends, both in the previous picture and this picture, that gutter end just below your cursor is supposed to be a minimum of 1 inch away from the siding. There's actually supposed to be an air gap between the end of the gutter and whatever sheathing you've got.
Well, the siding, and I think that applies specifically to hardy plank. I don't know that that's a requirement for vinyl siding, but it certainly is not a bad idea. With hardy plank, that's a manufacturer's spec. I don't know that that exists with vinyl siding, and certainly, you know, it should be there with wood siding, but again, I don't know that there's any recommendation specifically for that. But with hardy plank, absolutely, that's in the manufacturer's installation instructions. Thank you, Bob. Here, no flashing, wood roof down. Hopefully there is a flashing underneath the siding. There should be a space between the wood roof and actually wood or hardy plank. The installation instructions are actually pretty similar. The concern with hardy plank and with wood is you're trying to limit the absorption of water into the siding. So ideally the wood or hardy plank should be an inch or two above the roof. You should see the flashing, and there should be kick-out flashings. Here you can just see literally the water runs down the roof and drains in the joint. I mean, this is, you know, basically a terrible installation of plywood siding. There's no flashing over the window. There should be a Z flashing at the horizontal joint. And you can also see the water is being wicked up into the siding there and ultimately deteriorating the plywood siding. This is 2 condo roofs where they stagger the buildings front to back. There's like a little 2-inch difference between the roof heights. There should ideally, sometimes you'll see a little bitty flashing installed there. Here they just ran the shingles. When they re-roof, they just ran the shingles over onto the adjacent condo, and you know, flashing should be there, hard to say. This is your little 2-inch roof. They didn't run the shingles over, but you lift, you can see the top of the flashings. There should be a drip edge or something keeping the water out of that. You will see the stains on in your client's attic if this is the roof of the home you're inspecting. These balconies where they poke the balcony out the side wall, there should be a horseshoe flashing installed over every joist that extends a few inches out that you should be able to see. These are never flashed properly. I can pretty much guarantee you they're never flashed properly. Doesn't make any difference. You just have water getting down. They're following these joists back in. These things are just going to be replaced wholesale 5, 10, 15 years. With any amount of luck, not too many of them collapse before they start replacing them. And these joists go back. If they stick out 3 feet, they should go back in at least 3 feet. So if they're sticking out 3 feet, they should run 9 feet back in. When these start to rot and fail, water gets inside the framing around the joists. If the joists themselves aren't rotting, the framing supporting them is rotting. There are going to be major failures and replacements. Big bucks involved in this. Here, with the manufactured stone, the stone is supposed to be at least 2 inches up. You're supposed to have a flashing in there. When it's time to replace this roof at some point in the future, they're going to have to, you know, who the heck knows, leave the existing step flashing. There should be a kick out here. The gutter should be, the manufactured stone is the same as stucco, is the same as hardy plank. The gutter should be an inch away. There should be a kick out flashing. What do you tell your client buying a situation like this? It's not right. It potentially can be very problematic. You can have significant damage to your structure behind the stone. You can't see it. You can't see it in the house a lot of times. It's on the outside portions of the framing. Caulking might be some sort of a temporary help, but it has the potential for being a real mess. And you want to emphasize that in your report, not just saying it to your client, but it should be noted in your report, should be noted as a problem item, even though no visible defects are showing.
Hey, Dave.
Yes, sir.
That last slide, they should have a 2-inch clearance over those shingles.
Yeah, it should be. You should have 2-inch space between the shingles and the manufactured stone. That's correct.
And definitely a kick out.
You should see your flashing in there.
Yeah.
You should see your step flashing. You should see your kick out. And I mean, if you don't see it, again, your client's potentially buying the house. And it's the devil to fix. You know, the stone comes off. You don't just carve out 2 inches of stone off the bottom. The stone comes off, the flashing installed properly, and then somebody's got to try and patch that stone back in. So it's the devil to repair, and there can be no damage behind that. There can be significant damage behind it. It's a risk.
Dave, if you see any stains on the lick and stick, do you recommend a destructive investigation in that corner?
Actually, with this stuff, I'm starting to recommend at least the magic moisture meter that goes 2 inches in. Potentially an infrared inspection on the inside might show something like that if somebody goes and hoses it down and then gets the infrared camera on the inside. I recommend evaluation by a specialist. I don't tell them how to do it.
Real quick, shameless plug. Jim Vaughn and Sean Troxel are now EDI certified for this exact thing. So give us a call after this is over.
Super. Excellent. Well, thank you very much, both of you, for taking the initiative to get whatever that certification is. And I will be thrilled to take my responsibility for that off of myself and dump it on you. Absolutely. Thank you. Good luck with that. Hope you don't get burned. You're taking, you know, it's a risk, and I don't know what the heck you do to evaluate that. If you are you chopping it open, Sean?
Yeah, I'm drilling holes, at least drilling holes.
Okay. All right. Well, that's, you know, that's really the way that you have to, you know, drill a hole and stick a probe in and see how far it goes.
Yeah, and it's like 90% of walls that look like that have major damage going on.
Okay.
Water is going to get in. It's a matter of time, really.
Okay. And actually, when you're looking at details like this, you know it's a 5 or 10-year-old installation. Because really, when they're putting it up now, you know, pretty much most of the builders, they do have a clue about this stuff now. They've all been tagged on it. Thank you. Here, your stucco is maybe a 1/2 inch up, so that's certainly better. This was probably at this point was maybe a 15-year-old house. But you're taking it, you're aiming the water at a wall, and you're taking the downspout and dumping piles of water at a situation that has, you know, marginal or tenuous slashing at best. Whether you can see damage or not, recommend. And destructive testing is basically drilling some holes. But there's the potential for lots of damage in these situations. So again, this is stuff, this is no miss stuff. And looking at this roof from the ground, that could be a situation that you could easily miss. So you want to at least, you know, my recommendation is at a minimum, take your ladder. If you don't walk the roof, put your ladder up on the gutter and look at everything. Lift the shingles at the eaves. That'll let you see details like this to call out issues.
Hey, Dave.
Yes, sir.
Sorry to keep interrupting. One thing on the last slide.
I asked for it.
Can you talk about the requirements for dimensional shingles on low slope roof real quick? There was a question about it before. On low slope roofs, do the same rules apply for architectural shingles? I think they're talking about the pitch.
To the best of my knowledge, yes. But that I do not have a specific answer for that. It's an excellent question. I have not researched, you know, I do not know, but to the best of my knowledge, if you put that ice guard underneath, it's basically the same sort of installation. You're sealing around the nails. I don't see why it wouldn't work, but I do not have an absolute, you know, I've looked that up. Yes, you can. No, you can't. If anybody does know, you know, again, toss it in the chat box or chime in.
Hey, Dave.
Yes.
I thought it required 2 layers of self-healing ice and snow guard. That's what I saw the last time I looked it up.
2 layers of 15-pound felt over the ice and snow guard?
No, 2 layers of self-healing ice and snow guard.
or the ice and snow guard?
No, no. Once your pitch gets too low for just a regular installation, the last
Less
time I
than
looked,
fourth
it said
felt.
2 layers of self-healing ice and snow guard.
2 layers of felt. What is that word? And then ice and snow guard.
No, 2 layers of ice and snow guard.
I
No,
have not seen that.
yeah, that's the last time I looked. 2 layers of ice and snow guard.
Okay, well, I can, yeah, with the dimensional shingles or all
And
shingles.
all shingles.
I honestly don't know, and I do know there's certainly varying degrees of the ice and snow guard. There's the gray stuff that's like an 1/8 inch thick. I don't think you need 2 layers of that. There's the new stuff now that's basically sticky felt paper. I could certainly see that, on a low pitch roof, you'd need 2 layers, potentially need 2 layers of that, but I'm not familiar with specific instructions on that. But basically what's underneath once you get past the eave is hard to say. I've never seen 2 layers of ice dam material on any edge of any, roof that I've seen. But I'll be happy to look those up.
There's a technically advisory bulletin out by GAF that reads for low slope as well as other slopes requires 2 layers of protection. It doesn't say ice and water shield. It specifically says 2 layers of protection, but it doesn't say ice and water shield.
Well, you can put 2 layers of felt paper underneath, and you're supposed to spread tar in between the 2 layers of felt paper. That's always been an option, but since they came out with the ice and snow guard, I haven't, you don't see anybody smear it, mopping tar on felt paper any longer.
Yeah, the bulletin reads a double layer of roof deck protection is required. GAF recommends, and then it goes on to Shingle Mate, Roof Pro, 15 or 30 pound felt, Tiger Paw or Deck Armor, roof deck protection. So they give you lots of options, but it's just a double layer.
Okay, thank you. That would be under the entire roof.
The whole low slope area, yeah.
Yeah, well, I have always called out for whether you can see it or not. I always just raise the question, has it been, is the appropriate underlayment there? This is the situation. This is underneath that situation where you see stains just coming out everywhere. So again, you look at this, you say, boy, that looks like a problem. And in the areas where you can see it, it is a problem. And this is on the hard coat stucco, so the water's just wholesale in that wall. That was an expensive house. Here, a metal roof to a stone wall, and somebody just simply gave up and just brought out the 5-gallon bucket of tar. Beautiful stone wall, nice metal roof. And there's a possibility the porch settled and that roof pulled away, and they just, they didn't know what to do but tar. Here again, you're taking water, aiming it down into a corner. Whatever the first installation was with the brown aluminum, it leaked. They put more aluminum on top of it, more sealant, and ultimately, that's still leaking. A proper fix would be build a cricket in there somehow and try and just channel the water out of the corner. But whenever you collect water and aim it at a wall, it's a leak. Here, there's a flashing, but the flashing's way too short. The water's just not getting around the corner. It has a possibility of just, up and in. Here, for some reason, there's some kind of step flashing under the vinyl siding with a metal, standing seam metal roof. I just looked at this. I don't know what's going on. I have no idea why it was done that way, but at this point, I've just given up on even trying to guess at why. You don't have enough information to answer the why question. With any amount of luck, the metal roof is turned up. And it might have been a siding installer just saying, well, I know I'm supposed to put step flashing in, let me put step flashing in. You can't even guess what their thought is.
Maybe their book was upside down. So they step flashed the vinyl.
It's just, you don't know. You can speculate all you like. There's just no logic in that. Valleys. It's your condos where you have the horizontal valley. It's about a shingle wide. It's about 12 inches wide. There should ideally be a piece of metal in there. Many times there's not. They just seal it and hope for the best. This is what you like to see. Piece of metal running underneath the whole thing with no nails in the metal that you can see. That should divert the water, and it's extended out past the shingles on both sides. That is not leaking. This is probably leaking. This most certainly is leaking. Bad. Better than bad. Good. And best does not create the situation in the first place, but that's beyond your control. Here, you're collecting a bunch of water, aiming it at a valley. You don't see any indication of a low slope roofing material, and who the heck knows what's going on under all those leaves. But again, pretty much assured there's leaks in there somewhere. Here, same situation, not covered with leaves, but you're collecting a bunch of water, aiming it, and then you've got a roof intersection here, a flashing intersection. It's just, that water's going to get down in there. No kick out flashing, no sealing at the top of the, whatever it's counter flashing or step flashing is there. Leaks. Aluminum expands and contracts. When you nail the aluminum valley flashing is supposed to be folded over with clips holding it so it can expand and contract. When the aluminum valley flashing is just nailed under the shingles, it's pinned, it still expands and contracts and will buckle. Aluminum, a very soft metal with very limited amount of flexing. You actually cut aluminum flashing with a knife and then you fold it several times and it just, it breaks at the slice. You do the same thing in a valley, you have leaks. And no easy fix for that. It's just take it apart and redo it. You tar it until you're tired of tarring it.
Dave?
Yes, sir.
On those long runs, because aluminum expands and contracts so much, most roofers recommend doing that long run as several pieces.
Yes.
So they can expand and contract and not tear the foolish thing out, because a long run like that could expand and contract over ½ an inch.
Yes, and multiple pieces lapped at the joints like 6 inches on the downhill. That's certainly a preferred method than one piece. Thank you.
Dave, I've also seen, I put in the chat, but I'll mention it before you leave the valley topic, is that I have on occasion seen woven valleys with architectural shingles. And as far as I know, that is not permitted with architectural shingles because of the thickness.
That's correct. A full weave rather than the half. You're referring to a woven valley where both shingles.
Yeah, where they interleave.
Yeah, this is a cut valley where one shingle goes up and the other is cut. Where they're weaving both sides.
Yes, exactly. They're weaving, and I've seen it with architectural, and that's not good. Yeah.
No, that is not a recommended installation. Actually, I don't know that I've actually seen that.
I'll send you a picture.
Super. I'll steal it for my seminar. I will appropriate it for my seminar. Thank you.
Nick wants to know why not.
Why not? Manufacturers don't approve it. And when you have the architectural shingles, flat like that, you're going to get lumps and gaps in the shingles. You can't weave them, and they don't lay flat. And when you have the water coming down the valley with velocity hitting the valley, it has the potential to go, across and under rather than be directed down the valley. Yeah, it's not an approved detail, and the reason the manufacturers don't approve it is that it's prone to leaking. Change in pitch. This is an area that manufacturers are requiring flashing. Now, the flashing can be, an aluminum flashing underneath. I see that rarely. It can be flashed with the ice dam material. But whenever there's a change in pitch, what happens is you'll get, particularly in a ventilated or a poorly ventilated attic, you'll get, well, actually, you'll almost never have proper ventilation in the attic in this area. You get warm air from the house melting the snow. It runs down, hits the low pitch roof, freezes, and then you'll get a huge ice dam in this area. You'll get a pond of water just sitting there, and that's when it's prone to leaking. So the manufacturers do require flashing in these valleys. The flashing, again, can be the ice dam material, something that seals around the nails. It can be metal flashing, but you don't know that that's there. You pretty much are hard pressed to see that. You might, if you lift the ends of the shingles where the low pitch roof dies into the steeper roof, you might be able to see an ice dam material there. Most likely you will just see 15-pound felt, and again, prone to leaking. Not in a rain situation. Once you put ice and snow on the roof and you get damming, that's when something that works great 90, 95, 98% of the time, given the lack of snow we're getting. But in, northern climates, you get up into, Pennsylvania, New York, New England, Canada, these things just leak like sieves. So there they understand how to, do the underlayment to prevent these. But there should be a flashing wherever a roof changes pitch. Here, your metal roof is basically self-flash, but when you run the change in pitch under the dormer, ideally you would have flashing running 6 or 8 inches up under all that wooden trim and that siding. You don't know, but you're inside. If you can get in the attic, look at these areas in the dormers when you're in the attic adjacent to it. If you can see those, look for stains. Here, you not only have a change in pitch, you have a change in material. This was the roof yesterday. The slates are deteriorated, so it's leaking. When you see a situation like this, ideally, you want to see that the metal roof, the low pitch roof, actually runs up 18 inches or 2 feet onto the steep roof, and you should have the low pitch roof visible. You should not have the shingle or, in this particular case, slate roof running right down to the low pitch roof, because again, what you have with the ice dam issue is your shingle roof is filled with nails. So the metal roof that runs up and under, you've got holes there. Snow melt runs down, hits the low pitch roof, you get your ice dam, and you basically get your ice dam sitting on the asphalt shingles or slate that's full of holes. So the ice dam material should run up, or you should see the low pitch material run up onto the steeper roof, and then ideally the shingles should be 1 foot or 18 inches up off of that change in pitch. This is basically, it's a leak, and actually I have photos of, this is an active leak. There were stains all along this ceiling and wall intersection here. Again, this was an addition. This house had, 5 or 10, somewhere between 4 and 6 different additions over time with it. Here you just have a mess. Penetrations running through where you're going to get ice and snow buildup. You've got a windowsill. You've got a downspout dumping. You've got a plumbing vent that was leaking, and crazy foam. You know, the foam in a can used to fix it. You know, this is just a mess. Get the downspout water out. Figure out some way to run the refrigerant line and the electrical power lines where you're not running it through a hole in the roof. Collect the water, aim it at the vinyl siding with your 3-inch tall step flashing running up under it. Drain a gutter into that. Again, you know, this is leaking, whether you can see it or not. If you can get in the attic, you'll be able to photograph that and show the staining and leaking. There's no question, this is a leak. Yes, it needs to be repaired. You don't really need somebody to say that it is a leak. It is a leak. Put a plumbing vent near the delicate situation. Again, you know, a lot of times these are additions where other roofs are brought into play. 3 roofs draining into a valley. You've got a flashing that it terminates there, and put a hole in the roof and load the thing up with ice and snow. You do have step flashing and counter flashing. The step flashing has not been properly installed. The counter flashing was just slapped to the side of the brick and just sealed multiple times. No cricket there. Collecting the water, draining it at the brick chimney, so the water's running down the side of the chimney in the attic. It's also probably running down onto the ceilings. You know, it's just a mess. That's a problematic design. Funky installation. This again was the house I saw yesterday, where with an addition coming into an addition, a couple of windows, the window sills are sitting down. This is actually, you know, it's a EPDM, EDPM. I can never get it straight. They're flat roofing material. They've actually kept the siding up a couple inches, but you got a windowsill. Again, it seems to be working fine. There were no stains on the window, no stains under each window, no stains on the ceiling. Well, actually, I did have stains on the ceiling. Here, I had stains on the ceiling were here. There were no visible stains anywhere here, but you load it up with ice and snow, you know, water's going to find its way. All these are just, they're sealant joints. Nothing else you can do. Pile up the snow and it's going to leak. Again, a situation that, you know, the roofer's going to fix it. The roofer here did a very credible job, but under the wrong situation, you know, it's 100%, it's got to leak at some point. You know, what can you do with it? What can a roofer do with a situation like that? You don't need to get on a roof to see these situations. This was a relatively low slope, 1-story addition, got up there, a lot of photos, but I knew that was leaking when I was in the bedroom looking out the window. Again, you take a photo like this. It's not the ideal photo, but if you're not climbing the roof, you're not getting out and looking at it. You open the window, take a photo through the window. If you can raise the screen and get out, you can take more photos, but this is all you need. Again, you don't need to document perfectly. You just need to document this is a problematic situation. You don't have to get on the roof. Here, the windowsill actually runs below the level of the roof. You just can't possibly not leak. You know, how many negatives do you want to put in a sentence? But, you know, it is leaking. Maybe not every rain, but you get a good hard rain, it's leaking. It can't, again, the windowsill is below the level of the roof. You can't keep water out of there. You can't seal that to make it not leak. Down here, you can just see it's not a step flashing. It's a one-piece flashing, but it just terminates. That's a hole that's just letting water in wholesale. Having a door step out onto a low-pitch roof, you know, besides the fact that somebody can open the door, walk out on a roof and fall 10, 15 feet, you know, guardrail issues are, you know, obvious there. But again, this is something that it's almost impossible to flash that and not make that not have a leak at some point. Initially, if the roof is run completely under the door threshold and up the wall and around, that would work for the first roof, but once it's time to re-roof it, they simply can't, they would need to take that entire door apart, take it out, run the roofing completely in, make a pan, and then put everything back. They're just not, the roofer's just not going to do that. Here you've got a flat roof, the wood framing, a metal roof probably had some pitch at some point, but the stone wall did not shrink. Wood framing under deflection and load, who knows how they actually framed underneath it, but now you have a negative pitch. Your metal roof just turns up to the windowsill, is sealed, the water's just sitting there laying, so there are, again, that's a leak. And then you put ice and snow on it, and, that's just a bigger leak. Here they're running the flashings up the wood to the underside of the siding. Not a bad situation, or the best of a bad situation, but then you put a windowsill in it. How can you make, these are just, you look at it, you just photograph it, it's leaking. Well, we don't see any sign. I'm sorry, it's leaking. It's collect water. You can see the leak right there, no matter what they did to flash it. And this is usually an addition. The window was there first. The addition came with the roof running. Well, let's, get it as the steep a roof pitch as possible. But again, you're just, it's a leak. Whoops, forgot to install the caps on the ridge vent. These are the joints in the ridge vent. So, something that roofs typically don't leak at the ridge, but when you leave a hole at the ridge, yes, they do leak. The sheathing's deteriorated. Trusses look all right. And again, ideally, they're not running the 8-inch strip of sheathing. They want to have a 2-foot piece of sheathing at the ridge. That's what you see today. The older ones, they would just run anywhere from 8 inches. Sometimes you'd have 2 or 3 inch pieces there. So when they nailed the ridge vent, it was nailed into basically nothing. These are your old townhomes a lot of times. Low pitch roofs or flat roofs. No roof should ever be flat. Every roof should have a teens of pitch to drain. Oh, thank you, Devin. The actual chemical name for the EDPM roof. Materials, EDPM. I did get it right. I spell checked before I put the presentation together. This is, I don't know how many times I've given this at this point. So it's typically called a rubber roof, but it's not rubber. It is ethylene, polypropylene, diene, monomer, rubber.
Actually, Dave, both you and Devin have it wrong.
Okay. EPDM?
Right.
So why do you have a question mark?
Yeah.
It should be EDPM exclamation point.
Dave, I can't even be
That's what he
right.
meant to write. I think Devin knows. He meant to write.
I can't even be right when I'm right.
Hey, I put in 4 errors in every presentation, and I'm just checking to see who is paying attention. And I don't know which 4 errors I've put in the presentation. Modified bitumen. Basically, either of these materials, you can make a bowl out of the material and it will not leak. Metal roofs can be installed, but when they go less than, theoretically, you shouldn't have metal roof on less than 1 in 12 pitch, but I think below like 3 in 12, it shouldn't be a standing seam metal. It should be a flat seam metal with all the seams soldered. Roll roofing, inexpensive. It's not approved for habitable spaces. You do see it occasionally, but not much anymore since they've come out with the EPDM or the EDPM and the modified bitumen. Tar and gravel, you see that on older roofs, but you no longer see that in new construction. You do if you do inspections in Baltimore, DC, you will see tar and gravel, but replacement of that, nobody's putting Well, I would imagine you get some neighborhoods they're still slathering tar on the tar and gravel where people don't have any money to replace them.
A lot in downtown Baltimore.
Yeah, lot in Baltimore where nobody's got 2 nickels to rub together.
The torch down roofs, are those a version of EDPM?
They're the modified bitumen.
Okay.
The EPDM or EDPM is a rubber roof. Those seams are glued. Modified bitumen can be either peel and stick or torch applied. They're called the burn down roofing. They have burned down a lot of buildings, particularly
They're scary.
old churches with flat roofs.
If you ever get a chance to see one being done, videotape it because it's scary.
Oh, I've installed them. I've actually been trained to install them, so I have installed them. It's a torch. It's really not bad, but where it runs up into the wood, when they're installed, they're supposed to be, once everything is done, there's supposed to be a person left behind with a hose. There's supposed to be a hose on the roof when they're being installed. Oh, I'm not kidding. That's a manufacturer's guideline. There's supposed to be a hose, a live hose on the roof when they're being installed. There's supposed to be a person once the installation is done for the day, there's supposed to be a person on the roof for at least an hour with that hose. Because they're,
Dave, you're so funny, Dave. You're funny, Dave. You're funny, Dave.
No, this is with this stuff. This is how it's supposed to be installed. That's how I was trained. It's supposed to be somebody sitting on the roof. But basically, the torch sets the dust in the wall on fire. The dust smolders. But it's not the sheathing itself where it gets burned down. There's a layer of felt. There's an underlayment that the material is melded. Basically, with your torch, you're melding the material, and it sticks. You're only melding it at the laps. It's not melded under the entire width of the roll. But the problems are where it runs into the wooden walls, you're heating it and putting pieces of flashing, cut. The roof is flashed with strips of the material cut, heated up, and just slapped down at the intersections. That's how you flash it. It's a very effective system, but when they're using the torch close to the wood walls, you're basically putting a torch next to a wood wall filled with dust. The rubber roof, the EDPDM, is in big sheets. Roll roofing and modified asphalt are in actually 39-inch rolls with a 3-inch lap. This is your EPDM, EDPM, your rubber roof. There's an underlayment that is nailed down with the big washers, so seeing the fasteners through the rubber roof on top is not problematic. That's how it's installed. This is a cured material for the field. There's an uncured material that is the flashing that seals the field material to the metal flashings. That is an adhesive. This is not a burn down roof. This is a glued seam. This is the rubber. You can see is the large sheets that's rolled out with as few seams in the field as possible. You get a really large roof, you will have seams through the field. They're glued, and then there's a flashing. Again, the uncured material is glued on top as a flashing. And this makes the seal between the EPDM roofing and the metal flashing. You don't join the field material directly to the flashing. There's the uncured material that's sealed over top of it. This is actually this is a good installation of this material. You're not looking at a problematic installation. You're looking at, what it should look like when you're inspecting it. You can see sometimes there's a sealant at the joints. I got one more sentence, then I'll let you in, Sean.
Go ahead. Yeah, go ahead.
Crap. Come and gone.
I'm sorry.
No. It's not your fault. This is brain. This material is not compatible with asphalt. When tar is used or tar, asphalt, any petroleum-based product is incompatible with repairing this. Tar will rot this. So if somebody has a problem with this stuff and they're slapping tar on it, they're basically rotting the material out. That's just terribly problematic. Sean, yes.
I was just going to say, Jeff was asking what the ways to tell the difference between rolled roofing and modified bitumen.
Excellent. I do have actually a couple shots of rolled roofing, but basically you take an edge, modified bitumen, somebody has figured out how to get hot tar in a roll with a fiberglass membrane in the middle of that roll. So roll roofing has no fiberglass membrane. You can take the edge of the roll roofing and you can tear it. If you can't tear it, it's modified bitumen. If you can tear it, it's roll roofing. That's an excellent question. Thank you very much, Jeff.
Doesn't roll roofing also have many more layers because the overlap is so large?
Maybe. There's single coverage roll roofing, which is basically not intended to be. I've got a couple shots of roll roofing actually, so we'll get to roll roofing. I can answer that question a little better when we're looking at it.
Hey,
Here
Dave.
again, yes.
Can you go back one slide? How do they seal the vertical edge there to keep it from leaking?
This is all an adhesive.
No.
So-
See where you've got the vertical, I guess, aluminum flashing. Is that tucked under or nailed under
This is
first?
the edge of the aluminum flashing right here.
Okay.
This flashing runs back here. That's that line you're looking at is the end of the aluminum flashing. So the field material is run all the way out to the edge. The drip edge here it's actually got a gravel stop. It doesn't need to stick up that much, but it actually extends 4 inches out onto the field. And so this flashing material is sealing the joint, but the joint is not right at this edge. The joint between the two materials is actually here, buried under that flashing. Did that answer your question? Was that done?
Yeah, thank you.
Yes. Yeah, so again, this is an adhered flashing material, and the joint is buried under the flashing material. So, when you're inspecting these, all these edges of this flashing material, every inch of it should be down tight. You should not see any fish mouths. You should not be able to lift any of this. If you can lift these edges, that's a defect.
That's a leak.
Again, they can be, simply adhered down, but that should all be sealed down tight where you should not be able to lift anything. You shouldn't see any fish mouths. You shouldn't see anytime you're looking at a gap in this, you're looking at the potential for a leak. Again, this is the edge of the drip edge running back here. So if you have a fish mouth here, it's letting water potentially in and under to the edge of the drip edge flashing at that end. There is a piece of metal here, but it doesn't. This is a gravel stop. It turns up to keep the water off the edge. This is basically an L-shaped drip edge that's about 3 inches long. And actually, oddly enough, you have a reverse detail here. The field of the EPDM is run down to the edge. Your metal drip edge is installed on top, and then the uncured flashing material covers it. But again, you're looking at the metal edge of the flashing here. You're also looking at the metal edge of the flashing here, and that's how that gets installed. Here you've got the EPDM. Most likely they've run the shingles right down to the edge. What you really want to see in this situation, besides not having all the leaves, you can actually see it, is the flat roof material should run 1 foot or 18 inches up the slope. The shingles should be brought down, but they should not be brought down to the edge of the flat roofing. You should have 1 foot or 18 inches of the flat roofing material run up the slope, and then the shingles start. So the flat roofing material should run probably 30 inches up the slope. and the shingles run down on the top 12 inches of that 30 inches. So basically when the ice dams in this area, it's not if the ice dams, it's when the ice dams. There's no nails, that it's a flat roofing material that's got the pond of water sitting on it, not shingles with a nail every 12 by 5 inches. The roll roofing 36 inches, that's incorrect. Roll roofing is also 39-inch rolls, but they lap at 3 inches. The modified bitumen is 39-inch rolls and they lap at 3 inches. So both the roll roofing and the modified bitumen are 39 inches. They lap 3 inches, but you can tear the roll roofing. You can't tear the modified bitumen. Just go to an edge and just try and make a little tear in it. You're not creating a leak. You're determining what the material is. This again is your rubber roof. There should be no ponding on that. There's some ponding usually. And if it's not raining, you can still see the outlines of the ponds in the, there's little bits of dirt when you have ponding on a roof. Those roofs should have no ponding. The maximum permissible ponding on a low pitch roof is 0. Here's your modified bitumen, and I do have some slides for the roll roofing, so I'll be able to show you a couple of the questions about the roll roofing. This is the modified bitumen. It looks for all the world like the roll roofing. And this is actually how you do the flashing. You've got your penetrations. You take and this is the torch applied. They actually cut these individual pieces of material. They heat them up and they just slap them down on top. And even with the ideal situation with the modified bitumen is you have material that does not have any granules. And then you're basically sealing melted material to melted material. You heat both the upper and lower layer with the torch, whether there's granules or not. But when there's no granules, you've got basically liquid bitumen on both surfaces that are meeting. Here you heat both the upper and lower, but you're dropping your flashing pieces down on the granules. So you've heated the granules. There's a little bit of melted material in between the granules, and then you drop a melted piece of the flashing material on top. And there's the 2 lower pieces. They heat it and slap it, and then sometimes they'll seal these, but each individual piece, you're holding it, heating it with a torch, and then slapping it down while it's still molten, while it's still melted, and you heat it enough so it melts, but you don't heat it too much that all the bitumen just starts dripping off on the roof. Pipe penetrations through the roof, you just heat and wrap that material while it's still hot and molten, wrap it around it, and then the top is sealed either with basically just with tar in a can. So there's just regular maintenance on a joint like this. This again, the only way to really finish seal that is with roof cement in the tube, and it's just an area that needs regular maintenance.
Hey, Dave.
Yes.
I see that there are manufactured products made for the plumbing stack.
You can get manufactured flashings that will now just fit over the stacks and they just set the material around it. Yeah, these are older installations, but they're coming out with more and more, products to work with these situations. Thank you, Jim. Look at the details carefully. Ideally, your siding should be up off the roof. You should see the roof turn up. Here, you don't know what this is, but there was an older roof. You've got the modified bitumen turned up. You've got the flashing material. And instead of running another piece of modified bitumen up and under, I guess they didn't want to lift the metal, peel the metal flashings back away. It's either the original roof, it's a piece of felt paper or something, you don't know what it is, and just slathered with tar. So, and you've got your water just hitting this corner running down. You're pretty certain that this material doesn't run very far behind the vinyl siding. So, a problematic installation. Again, you don't really need to recommend somebody evaluate it. It is a problem. You want somebody to come out, take the whole thing apart, put the roofing up properly, and then reinstall the siding and a counter flashing. Metal roofs. Here is what you really want to see, where you have the change between your metal roof and your shingles, where the metal roof actually runs up the sloped roof. The shingles are brought down on top of the metal roof, but the shingles stop a foot or 18 inches away from the change in pitch, that you've got no fasteners in this area. This is a critical area. The situation was done properly. You wound up having to do a horizontal seam. You might be a little touchy in these areas. You had to do a horizontal seam, I would imagine, because the dorm are kicking out there. So they've got, 1, 2, 3 planes, 4 planes intersecting in a very limited area. But again, what you want to see is the metal roof running up the sloped roof, and then the shingles coming down and stopping. You don't want to see the shingles running all the way down to this line. Here you have the metal roof is just turned up and run into the brick. The porch itself, it looks like it's settling. You can see it's pulling away from the house a little bit. It's just pulling the metal roof out and away. And you have, openings and leaks. This is your built-in valley. There's draining. Look at these areas very carefully. Don't walk in them. Don't step in these if you're on this roof inspecting it. Do not step in these gutters. Step over them. Step around them. Don't get on it. Do not step in these. Sometimes the metal is stretched, or if it's it's a modern low slope roofing system, the material is stretched. The material should not be stretched. But if you step in it, you can be the cause of the failure. Something that was working, but now it's got a tear in it, and that's a pretty good leak. So do not step in these valleys. Actually, good rule of thumb, don't step in any valley.
Don't step on any bubbles either.
Don't step on any bubbles. Yep. Avoid tender looking situations, because you can be the cause of the leak. You've got a flat roof draining, multiple intersections, and you put your heat pump or your air conditioner on it. You just tar the living daylights out of it and hope it doesn't leak until the check clears. Again, this is just, you can call it whatever you like in your report. I mean, it's just a mess. It's just, you've got leaks everywhere on that one. And just haphazard attempts at repair. Here's your roll roofing. There's single coverage and double coverage roll roofing. Single coverage should not be installed on a house. There's your single coverage. This is double coverage. Again, these rolls are all 39 inches. The double coverage, they actually lap it every 18 inches, so that you have 2 layers of material when you have a double, and this is also referred to as a selvage roof. S-E-L-V, I think E-D-G-E or A-D-G-E, a selvage roof. But basically roll roofing, it's an inexpensive roof. But when you see the 18-inch laps, that's not 20-inch material, that's 36-inch material, but it's lapped twice. So you can actually have cracks and holes in the top layer, and you've got an entire full thickness layer underneath it that is still shedding water. So a double coverage roof, you have 2 layers of material, you need holes in both layers of material, and you can get holes in both layers of material. When they start the roof, there should be a 20-inch layer, 21-inch layer of material, and then your first layer of the 39-inch material is laid, and then it laps every 18 inches. So there should be 2 layers of material with the double coverage roofing. Here you can kind of see the top layer is gone. There's a bottom layer there, and there's drip edges shot. So, I mean, this roof is, not limited life expectancy. This roof needs to be replaced. and you put enough photos in your report that look like that, and it doesn't, your client's going to get it. This is a single coverage material that was 36 inches wide on a roof that has almost no pitch and leak from day one. And so the solution was just keep tarring it, and, put the buckets in the room underneath it, put the buckets in the coffee cans. And, there's no attic there, so you've got them down on the floor, put the plastic sheet over the furniture. The material, when it's installed, you're supposed to put the one layer of material down in the top edge of the material. And then when you install your next layer of material, it actually covers the nail. So properly installed, you don't see any fasteners visible in this material. This is someone who didn't read the directions, so you now have, and when they're installing it like this, they're probably running a single coverage. So you're looking at basically holes in the roof, whether it's single or double coverage. Every time you're looking at a nail in this material, you're looking at a hole in the roof, and a hole equals leak. Tar and gravel. I've done one or two homes in Baltimore, and darn if I can remember where they were, so I have no photos of tar and gravel. Thermoplastic overlay, TPO, it's called. This is a plastic material. It is not and should not be mistaken for any other type of roofing. It looks similar to the EDPM, and there's EDPM or EPDM in white. You can get it in white or black. This is a plastic material that actually, as far as anybody knows, lasts 20, 25 years. It comes in big sheets. You get it basically for the size of the roof. And I don't know, I'm sure there's a finite limit if you're on a commercial building, 50 or 40 or 50 foot widths, rolls, but it's huge rolls. It's turned up, it's self-flashing, and then you have a counter flashing over top of it. That's how this stuff is installed. The laps are made to shed water. I don't know that there's really no, I don't know how this would be adhered in joints that need adhering. But this is a relatively new product within the last 10 years, I believe. You see it on commercial buildings. I have not seen this residentially.
Dave, this is Bob Sisson. I have seen it. I've seen it a lot on the roof decks.
Well, you're not seeing this. What you're seeing is Duradeck, which we're going to get to. This is thermoplastic overlay. You should not see this on decks. It's not a walkable roof.
Dave.
You're seeing ponding. I got a 5-minute warning, so I'm going to have to limit questions just to roll, if you don't mind. And I'll take questions after we hit our time. I'll be happy to. Fiberglass sheet. This is a porch. Don't walk on this stuff. You will go right through it. Duradeck. This is the material that you're seeing on the balconies, on the decks. This is a walkable roofing material. It has an odd termination bar. This is how the stuff is terminated. This is approved for use. You want to tell your clients, don't, any furniture that goes on it, it is possible to put furniture on it, but you want to make sure they've got, cushions on the legs, coasters on the legs, something that's not going to put little holes and tears in it. Also, this particular one, it's running to a couple of door thresholds. There were doors on each end of the balcony. This is actually, they ran a downspout, a gutter and downspout there. They put a built-in gutter on this guy. Actually just set this is cast concrete railing, guardrail, just sitting on the roof, but it weighed so much you couldn't budge it. This is the termination bar. They had a built-in gutter running it to a downspout, not many trees around it. This is the detail that's on a leak.
Yep.
The material just wasn't sealed to the door threshold. It was turned up, and you're looking at, the loose material there. So sooner or later, that baby's going to leak. Balconies. Whenever you have a balcony, whether you can see it or not, there should be a roofing material there. You also want to look at your guardrails on the balconies. You want to look at a wear surface. Sometimes there's a wear surface over a roof. Sometimes there's a combination. The DuraDeck, that is a walkable roof. It's designed to be a deck and a roof. But this is the only material that really works for that. There's a space beneath, habitable or not habitable with your balconies. The guardrails either through the roof or on the roof. Your guardrail is actually, there's a roofing material, there's a post, there's a 4x4 post. The roofing material is installed all the way up the post. The balcony rail sits over top of the post. That's an old carpenter teach me that works. Here you've got a balcony, you've got a ceiling, and you got a wood floor. Somewhere under that wood floor there should be a roof. So you're down looking underneath these, look for signs of leaks. Also, this is in Winchester. That's a balcony. I had no idea what was holding that balcony up for 100 years. The guy that bought that, I don't know whether it needed it or not, but they took that entire thing apart and they just replaced it. They ran beams all the way back into that building. But there's your wood floor, there's your ceiling. Somewhere in there's got to be a roof shedding water. But looking at the underside, you can see, it's 100 years old. There's some failures, but something's keeping that dry. When you get modifications and changes, maybe not so much. Same situation, there's your wood floor. You hope there's a roof. You've got, an exposed faster cheap metal roof shoved under it. Look underneath this in the habitable room underneath, look for signs of failure, and there's problems. And this guardrail, again, you sneeze and that would move. It's not holding what it's got to hold. There's a wood floor, there's a wood ceiling. Somewhere there's got to be something that's keeping that guy dry. This is the plywood underneath. There were no signs of stains on it, and the plywood wasn't brand new. Your little Juliet balconies. These are roofs. There's stone. There's all kinds of flashing details. So when you see these outside, you're inside looking, and even if you don't see signs, you just indicate the problem. The guardrail screwed through the roof. There's 4 holes at every one of these guardrail attachment points. Another balcony. Leaks, leaks, leaks. Leaks. And this was like a 2 or 3 year old house in Ashburn, Lansdowne. Leaks, leaks. So just scream, whether you can see it or not. But this, again, 3 year old house, there were signs there's water in this stuff. All had to be taken apart, re-roofed. It's all just leaking. And if it's manufactured framing, there's serious compromise to the structure very quickly. Just an ugly situation, tons of penetrations, chimneys, flat roofing system. Just look at all these details. Here's your leg collars being bent up and around and sealed. Again, just a total disaster from day one. It's been leaking and just patched. These things, if somebody can get out onto that, that's an absolute hazard. You want to get up. A lot of these are 2-story windows. You can't see. Get your ladder. Put it gingerly on the rail. Don't assume the rail's going to hold you. Just leaks, 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 leaks. 100-year-old leaks. Skylights. Curb mount above the roof plane, roof mount on the roof plane, roof mount on the roof plane. They leak. They all leak. Glass and plastic. Glass might not leak. Plastic leaks. Velux is the only skylight that does not leak when it's properly installed, and it's difficult to install it wrong. There's Velux skylights, and there are every other type of skylight. Velux does not leak. You can identify Velux. They have a wooden frame inside. Even if it's painted, you can see like a 1-inch by 3-inch metal tag that if you could read it says Velux. That does not leak. Every other skylight, no matter who makes it, Pella, Anderson, cheap plastic knockoffs, they all leak under the right or the wrong situations. Up on curbs where the skylight is off the roof, you have a much better chance. You're looking for step flashings on the side rather than pan flashings. Whenever you're seeing, repairs on a skylight, that's a leak. Here, the skylight that should be installed vertically is installed horizontally, so you've got 4 feet of, you're trying to flash it, you put ice and snow on it, it's leaking, and then, this skylight's protecting this skylight, so this skylight is leaking less, but this skylight is leaking, this skylight is leaking a lot. Just an absolute abysmal mess. Leaking under the right situations, the larger the skylight, the more prone to leaking. Nice flashing job, but again, you look at this under a worst case scenario. A best case scenario, it doesn't leak, but if you have these in bathrooms, these are really common in bathrooms in the 80s and 90s. You can get humidity and condensation, but most times the stains in these are leaks. This is just 2 pieces of sliding glass out of a sliding, these are tempered insulated glass they're intended to be installed indoors, 100% leak. Cheap plastic skylight, it's a pan flashing, not a step flashing. It's a Wasco, it leaks. These round solar tubes, they seem to be pretty good. I have not seen them leaking. I've seen them installed the last 10 years. Glass skylights, this is a Velux. Plastic skylights, these are cheap, they leak, they just need to be replaced. They crack